Okay, class, today we're going to be taking a look at the residential energy code that's found in chapter 11, and we're just going to be discussing a little bit about the information that's contained in the chapter and some of my insights. And as usual, you will have a worksheet that goes along with this assignment this week, and you will be working on that. The energy code, as defined from the chapter, says that the provisions of this chapter will regulate the exterior envelope as well as the design, construction, and selection of heating, ventilation, and air conditioning systems, lighting and plumbing insulation required for the purposes of effective conservation of energy within a building or structure governed by this code. All conditioned spaces in residential buildings shall comply with, and then it refers to table N1101.1 parentheses 1 and 2 additional measures from table N110.1 parentheses 2. This particular energy code has been developing over a number of years. When I first started building years ago, you had some basic requirements for insulation and thermal efficiency in the envelope of the structure of the home. And this was a while ago, I have to admit. In a normal wall, you would have R11 or R13. In a 2x4 frame wall, you would have like an R30 in the ceiling, and when I first started, you didn't even have any insulation in the crawl space, so that wasn't even required. Window efficiency, door efficiency wasn't even recognized. In the early days, we had aluminum windows, and most all the windows, a lot of them single pane, and then they went to a double pane, which, if you think about it, doesn't make a lot of sense because of the efficiency of the frame transferred the hot and the cold so readily that I'm not sure that the double panes really made a whole lot of difference. Anyway, as a few years went by at that time, and this actually occurred with the local power company, PGE, they began a program called Good Sense. And then that program developed into another iteration called Super Good Sense. And I remember back in the day when my dad was still building, that PGE actually came to him and asked him if he'd be willing to do some test building to see how certain components of adding, additional thickness and insulation, different energy efficient windows, those kind of things. And so he said he'd be more than happy to do that. And I think he built 2 or 3, maybe 4 different houses with different conditions. And then PGE on their electrical meters added a feature where they could monitor those particular houses and compare the energy use compared to the lower standard of insulation that was being used at the time. So from my recollection years ago, this was kind of the beginning, or one of the beginnings here in this area, for the implementation of energy efficiency. And so chapter 11 here in the current code book is a combination of some of the ideas that have come about over the years and the requirements that are being specified so that we can have not only more comfortable homes, but also reduce energy use and maximize the energy use so that it's being used more in an efficient manner. When I think about this, from years ago, a lot of the things that they were talking about and developing were good ideas. But from my experience over the years as a builder, not all the things that they implemented actually produced good results, and I'll explain that. Basically, some of these original houses that PG asked my dad to build that were the Good Sense, and then I think the Super Good Sense, they switched over from 2x4 framing to 2x6 framing, which allowed them to put thicker insulation in the walls. Also, instead of using the craft face paper on the insulation that used to be the standard, they had them basically sheet the inside of the home with visqueen or plastic, and they would put the insulation in, and then they would put the plastic over it, and then they would drywall over that. Now, that did create a very tight envelope in the home, and it did improve the energy efficiency. One of the problems with that type of a situation, though, was that they began to close up the home and make it so tight that now what we're seeing, or what they found, is that you had reduced indoor air quality conditions, stagnant air, and in this area we do have some different gases and things that will radiate up out of the ground, like radon. And so the indoor air quality was being contaminated with some of these gases and those kinds of things. So it's been a little bit of a balance act to figure out what is the best combination of increased insulation and sealing the house to provide energy efficiency and to reduce energy consumption, but being aware that you have to have a certain amount of livability and air quality conditions. And so I know they've backed off of the visqueen. We don't use visqueen anymore. We've gone back to the craft face paper that the insulation used to have years ago. And basically what they've tried to do is create more of a structure that's breathable. The problem with the visqueen and the plastic, and also on the exterior, some of the house wraps that have been out for years, is that they create such a tight seal that now you create a condition for mold, dry rot, deterioration. And a lot of this condition is now detrimental to the house structure. And so I know we've backed off of the visqueen on the interior, and on the exterior they're requiring what they call rain screen, and different principles with the siding that should help so that the structure can actually breathe. Now, here not too many years ago, I built a home for myself personally, and when we got to the point where we were going to side the home, the siding contractor said to me, well, what do you want to use? And he wanted to know if I would be wrapping all the windows with the mastic tape, and if I'd be using like a Tyvek type building wrap. And he was quite surprised when I told him, no, we don't want to do any of that. No window wrap, no visqueen. We'll use the standard building paper that we've used for years. And that building paper that was used for many years is a permeable membrane. Even though it's waterproof, if you spray water on it, it's going to shed the water, but it will allow moisture to penetrate through it. And basically how that works is it's a breathable membrane. And I know they talk about like Tyvek and some of the other house wraps being breathable, but I know over the years, I'm not sure I saw the efficiency of that in those products. But I know because of years' experience with the building wrap, what they called snorkel paper or building wrap, it was a tar paper, it definitely did have breathability. And so in this part of the country, we have many different situations of weather condition. In the winter, we know it rains and rains and rains, and we have very damp, wet weather conditions. In the spring, it begins to dry out. In the summers, actually, we have pretty nice dry summers here, and not too bad falls usually, and then usually back into the rain cycle. So what I've found with my experience over the years is that if you build a structure, a home, what you want is breathability. A structure that has good thermal performance as far as insulation, but you also want that home to be able to breathe. And through the seasons, the home is naturally going to absorb moisture. The building materials, the wood, the drywall, siding products, whatever it is, naturally are going to absorb moisture slowly over a period of time as the humidity increases and the conditions change. But when the spring comes and summer comes and things begin to dry, that moisture then needs to escape or come back out. And so the conditions that I'm seeing in construction now, we do have the requirements for wall insulation, the R21 requirement, the ceiling insulation, which is going to be a requirement, and the underfloor insulation requirement. But also, if you remember back from some of the previous chapters, the foundation has to have a certain amount of venting and venting size requirements. The eave overhang and the roof ridge have to have certain venting requirements. And all of these things need to work together in combination to create this building envelope that we've been discussing to provide good breathability but good energy efficiency. Now, one of the things that this chapter is also including for energy efficiency is some of the electrical fixtures that we have, light fixtures. Some of those things are being required to have higher energy efficiency. Windows, doors, some of these things all are being increased basically over the last number of years to a level that gives good insulation, good livability, but the type of application for the insulation and the exterior siding is now being implemented in a way that it also is providing better breathability. And so Chapter 11, Energy Efficiency, is going to discuss some of these things. You'll be reading through the chapter, working on the worksheet, answering the questions, and if anything comes up, be sure to let me know via either email or the other online forums that are provided for you. Thank you, students, and I hope you have a great week. We'll talk to you again here next week. Have a good day.